Hi guys, so in this problem we are going to learn how to find elevation C1 like this elevation by applying the Bernoulli's equation. So they have given us the flow rate, the density of the water that's flowing through the pipe, the mu value, the E naught, the epsilon and the diameter of the pipe. So first we'll start out by applying this Bernoulli's equation. So this is my standard general Bernoulli's equation. So which means like pressure 1 divided by specific gravity plus velocity 1 square divided by 2g is at 1 H pump. Why I applied this H pump over here is because so I considered my this tank as my point 1 and this as my point 2. So always water will be flowing from point 1 to point 2. So then if I am flowing water from one point to another, I have to give it with energy, right? Like forget about this case where water will obviously flow downwards, whereas it's a standard general life situation. The water pump should be added to the side that we are pumping. So it's H pump and the head losses will be added to the other side. So if I take this, since the tanks are exposed to the atmosphere, the pressure P1 and pressure P2 will be 0. So as a result, these two sections of the equation will be 0. And these velocities will be 0 as well. And we will be left with the equation of Z1 equals Z2 plus HL. Why the pump is 0 is because we don't have a pump in the question. They haven't mentioned about a pump. So we assume that the pump is 0. So now that we know, we need to in order for us to find this elevation C1, we know it's a combination of C2 plus HL. And C2 they have already given us as 4 meters. So we need to find HL. So HL is the head loss. So to find head loss, we need to find the major head loss and the minor head loss. And in order for us to do that, we need to first start out by finding the velocity. So velocity, there is an equation that combines velocity with this data we have. So that's volume flow rate is equal to area into velocity. So we know that the volume flow rate is 6 liters per second. So to convert it into meters cubed per second, we multiply it by 10 to the power minus 3. And then the area of the pipe will be pi d square over 4. So d is 5 centimeters in meters, 0.05 square divided by 4. So we are left with this velocity of 3.056. So now that we have the velocity of the water flowing, we can calculate the total minor head loss. So minor head loss is the head loss through all these components, like all these bends and turns and everything. So the minor head loss will be equal. So the special thing about this question is the diameter of the pipe is constant throughout this whole system. So as a result, the velocity will stay constant. So this part of our equation will stay constant throughout this problem. So we can easily take that part to one side, add up all our loss coefficients and multiply by that. So the first loss coefficient would be KL of this entrance pipe. So that's 0.5. So 0.5 plus this bend is 0.3 and we have another bend like that over here. So that's 0.3 plus 0.3 KL due to this valve 0.2 and coming out KL like of this exit, which is 1.06. So you add everything up and divide by 3.056 the velocity square divided by 2g. So you are left with 1.12 meters. So now we have a minor head loss, but there is a tiny problem that comes up when we find the major head loss. So in the major head loss equation, we have something called this F, or the friction factor. So there are friction factor. To find the friction factor, if it changes if it's a turbulent flow and it changes if it's a laminar flow. So before we find this F, we need to figure out if our flow is a turbulent or a laminar. So I'll be applying this equation, which is rho velocity, mean velocity into the diameter equals divided by mu. So when I substitute in everything, I'm left with this Reynolds number of 116,908. which is greater than the range for turbulent, so therefore it's a turbulent flow. So now that we know this, it's a turbulent flow, we have two ways of finding this friction factor, either by using the Coolbrook equation or using the Moody chart. So I won't be explaining how I found that over here because it's a pretty long process. So I'll make another video on how to find the friction factor using the Moody chart and by applying Coolbrook equation. So I got this friction factor of 0.032, and now just substitute in everything for our major head loss equation, which is friction factor into length divided by distance, length divided by diameter, into mean velocity square divided by 2g. So I'll substitute in everything and I get a major head loss value of 27.1 meters. So after that, it's pretty simple. So we have Z1 equals Z2 plus HL. So our goal is to find this. So we know this is 4. Add up your major and minor head losses, which will give you 28.22. And then at the end, add both 4 and 28.2, which gives you 32.22 meters. So, and that's how you find the elevation applying Bernoulli's equation.